We have previously talked about triangles. We're going to talk about one more thing in triangles, Evan. Today's lesson should be a lot of review things. We've talked about how to classify triangles by the measure of their size. We've talked about how to classify triangles by the measure of their angles. Quickly fill in those 6 blanks, going down the left for the 3 and going down the right for the other 3. So an equilateral triangle has how many congruent sides? Adam? 3 congruent sides. An isosceles triangle has how many congruent sides? 2 congruent sides. And a scaling triangle has how many congruent sides? 0 congruent sides. Any questions on that? All right, on the right-hand side, a right triangle has 1 right angle. An acute triangle has 3 acute angles, and an obtuse triangle has 1 obtuse angle. So all those things, I'm pretty sure we have discussed already. We've used it several times. We've drawn different triangles, and we have worked with this several different times. The one thing we haven't worked with so much is the measure of the angles within a triangle. Okay? We've worked with marking the sides, so that if they're equal sides, we put little hash marks so we know those sides are equal. Okay, but we've not worked with a measure of the sides. We're going to take a look at the 3 triangles over here. The box indicates that the angle measures 90 degrees. Add up the measure of the angles in that triangle, please. Add up to measure the angles in that triangle, please. And add up the measure of the angles in the obtuse triangle. And in our obtuse triangle, they were 180. Every triangle, the sum of the angles is going to be 180. Every triangle, the sum of the angles is going to be 180. Okay? So take a look at the equilateral triangle. Notice the markings in the corners here. That means that those angles are all going to be congruent. Tell me what the measure of those angles are. Peyton, how did you get that, Peyton? There you go. Very good, Peyton. Oh. I just said all these angles are equal, right? And we know that every triangle, the sum of the angles is 180, right? And all three angles are equal, so we take 180, divide it equally among the three angles, and it is 60 degrees. Very good, Peyton. Okay? The puzzled look on most of your faces, and Peyton just whizzed right on through that. Thank you very much for that explanation. All right. So, can we do the same thing for the isosceles triangle and the scalene triangle? Yes. No, because they are not all equal. All right? They are not all equal. Okay? Now, when we take a look at an isosceles triangle, I'm going to draw the isosceles triangle this way, okay? In an isosceles triangle, these two angles will be measured the same. Does that make sense? Because these two sides are the same, so the two angles are going to be the same coming down into that base. Does that make sense? All right? So if I told you that this was a 20-degree angle, okay, what would be the measure of the two other angles? I don't think he has it. He thinks it's 70. But Lauren thinks it is what? He thinks it's what? 140? 440? 140. So we've got a 70 degrees. We have a 140 degrees. Anybody else? Peyton. He thinks it's 80 degrees. Anybody else? Tyler, how did you come up with your 70?
I thought it was 160, so I subtracted, I divided 160 divided by 20. So subtracted it, and then I got,
So how did you get your 160? Tell me that.
because I knew, like, I thought, okay, I don't know.
Yeah, you do. How did you get your 160? Tell us how you got your 160.
I don't know.
You didn't write anything down? Okay, here's a case of you're trying to do it all in your head, you don't write it down, so then you can't tell us what you did. Come on. Are we about to use in the 5th grade? How many times has Mrs. Allen said, write it down? Look, I know you had some good thoughts. I know you had some good thoughts. We wanted to hear it. All right. Peyton's got a turn. We're going to let somebody else have a turn. What do you think?
Okay, I think it's 70 degrees because I take 180 since all triangles have 180 degrees. And I subtract the 20 degrees from the angle we already know. I end up with 160, and then I divide 160 by 2.
When 2 goes into 16, how many times?
8. Wait, what am I saying? 8.
So can we go with that 80 degrees? Okay. You have the process correct? All right. beautiful process, right? Just made a little mistake of 16 divided by 2 is 7 instead of 8, okay? So good, 80 degrees. Anybody else come up with the 80 degrees? Okay, a couple of you. Questions on how we got that? Okay. All right, with the scalene triangle, we would have to know 2 of the 3 to figure out the third, right? Okay. So let's use this one, and let's assume that this one is 42 degrees. This one is, we're going to say, 50 degrees. Figure out the third one. This is 42 and this is 50. Eduardo, what you come up with? Anybody come up with anything besides 88 degrees? After you get done choking. 90? You might come up with any other amount. 92 degrees, anything else? 45 degrees, anything else? All right, somebody explain the process that they use. Eduardo. And you got? There we go. Good. Good. Okay. Questions on that? All right. Any questions on triangles? Good to go with that? All right. Next, we're going to take a look at circles. 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 We have not done much with circles. Circles. Not much.
You can't do anything with that.
How about we can?
Who doesn't have diagonal hurry with her? Wait, it doesn't have you with her. I got circle.
All right. Parts of a circle. Parts of a circle. First off, you need to understand that a circle, by definition, is a closed plane figure. By plane, that means that it's flat surface. Plane, flat surface. Okay? With all points on the figure the same distance from a point called the center of the circle. In other words, it's formed by, here's the center, all these points are the same distance from the center. Okay, they're all connected, they're on the flat surface. Okay? Circles are named by the center point. So what would this circle be called? Circle what? R. Circle R, because the center is R. All right? Okay? Now, when we start looking at other parts of a circle, the radius is the distance from the center out to the edge of the circle. So from R out to D, that would be a radius. From R to E would be a radius. From R to C would be a radius. Okay? We name a radius by its two endpoints. So we could call this radius dr, radius er, radius dr. A radius is those two letters. Whoops. It's a segment. It's a segment. And we put the segment symbol above it. Does that make sense? Okay? The plural for that, the plural is this right here. This is the plural of radius. Okay, that's the plural, radii. Okay? It's the plural of radius. Okay? Okay? So in these blanks, they're asking you to list all the radii, right? I named them. Go ahead and write them down. What's another one? They started with RC. What's another one? Segment ER. What's another one? Segment DR. Okay? Is AB a radii?
No.
Or radius, I mean. No, why not? Ezra.
It's not connected to R.
Yeah, it's got to be connected to R, this center. All right. All right? Questions on that part? All right. So if we take a look at the diameter then, the diameter goes across the circle, but it has to go through the center. Okay? We name the diameter by its two endpoints. In this particular circle, there's only one diameter, and it is segment CD. So the diameter of circle R is segment CD, or we could call it segment DC, as long as you name it by its two endpoints. Okay? We don't name it by 3 points, we name it by its two endpoints. Okay? But it has to go through the center. Okay? The two endpoints have to be on the circle. Now a chord. A chord is a segment that has two endpoints on the circle. There are two of them on this particular circle. Can anyone find one of them? Lane.
A and B.
Segment AB is one of them. Where's the other chord?
CD.
Segment CD. A diameter is a chord. It's a special chord that passes through the center. Okay? Does that make sense? Segment AB is a chord. It's got its two endpoints on the circle. But segment CD is a chord called a diameter because it goes through the center of the circle. The diameter is talked about a lot more than just one of these chords over here. Okay? Because a lot of people will use like a distance across the circle more than just somewhere on the circle. Okay? that make sense? Okay. Now, if you have to draw a circle, you use a compass. I'm going to tell you right now, every compass we bought for schools, they are not the most effective tools because you'd have to buy an expensive compass to make it work the best for a long time. And students break them really easily. Okay. We don't do a lot of construction of shapes in 5th grade anyway. When you get in geometry, you'll do a lot more. But to make a circle, you put the point of the compass down, and then you just hold that point down and just move the compass around, right? You can do the same thing with a string. Hold the string, put a pencil out here at the end of the string and move it around, but you got to keep the string tight, right? Okay? Does that make sense? The string would act as the radius, because the radius is the distance from the center out to the circle, and you always want the radius to be the same as you go around. Okay? All right? Does that make sense? Questions on that? Okay. The other thing I want to talk about is the relationship between the radius and the diameter. The relationship between the radius and the diameter. And we're going to do that using these two. Okay? We're not going to draw any circles with a certain radius or diameter. We're just going to use these two examples. If the radius is from the center to the edge, and the diameter is from edge to edge passing through the center, what can you say the relationship is between the radius and the diameter then? Peyton.
They both have to touch the center of the other, the diameter has to touch the center to reach the edge,
Mm-hmm.
and then the radius has to go to the center, but the other one has to go through.
Okay. All right.
Both lines are touching.
Okay. What can you say about their measurements, the relationship of their measurements? Right.
The diameter be bigger.
Would the diameter be bigger because it's around the circle? Does the diameter go around the circle?
No. The radius.
Look at the circle, look at the radius, look at the diameter. And what can you tell me about their measurements, the relationship of their measurements? We've been working on rules, right? There's a table. R is for radius, D is for diameter. What rule could we write if this held true? The diameter equals 2 times the radius. Take a look at the circle. If this is the radius and this is the radius, and this whole thing is the diameter. is 2 times the radius equal to the diameter. That makes sense? Okay. The diameter is always 2 times the radius. The diameter is always 2 times the radius. That makes sense? Okay. What if I started with the radius? The radius is always what compared to the diameter? What if I know the diameter? How do I find the radius? Tyler?
Divided by 2.
Yeah, or half the diameter. Yeah. The radius is always half the diameter. Does that make sense? Okay. So, when we take a look at number 2, I know that the radius is 2, and I'm looking for the diameter. I would use diameter equals 2 times the radius. Diameter equals 2 times, substitute in 2. So my diameter is going to equal 4 centimeters. Does that make sense? Eduardo?
Where did we get the other thing from?
This one?
Yeah, but that was just.
This one? The radius was 2 centimeters. The radius is 2 from here.
Where did you get the
This one, the diameter is twice the radius.
Oh.
That cleared up for you? Okay. Over here, we know the diameter, but we don't know the radius. So we're looking for the radius. The radius is half the diameter. The radius is half the diameter. Are you guys writing this stuff down? Or is that pencil dead? The radius equals 1/2. What's the diameter in this case? 3. So now we need to take 3 divided by 2. What is 3 divided by 2? What?
1.5. 1. Oh yeah, that's okay. 1.5.
It could be 1.5, 1.5, or 1 and 5/10, either one, right? Okay. Okay. Does that make sense? So we're using our rules of substitution and simplifying. We're using our formulas. We arrived at our formulas based on a table that I gave you to show a relationship between the diameter and the radius. Using a lot of math that we've learned this year. Questions? Okay. Let's take a look at this. What formula would we use if we know the diameter and we're looking for the radius? We know the diameter and we're looking for the radius. Abby? What would our substitution be? Now, because this is a decimal, let's make this a decimal. What would our decimal be for 1/2? For 1/2, Ezra.
0.5.
Okay. And now you can do 3 6/10 multiplied by 5/10. A lot of you forgot to use your estimation skills. If we want half of 3, are we going to get 18? How many places do we need to use that decimal point? How many places do we need to use the decimal point? A total of 2. How many places do we move the decimal point? 2, giving us what? Okay, so the radius is 1 8/10 centimeters. Okay? Number 10, we know the radius, we're looking for the diameter. What formula will we use? What formula will we use? Ezra. Go pass. Abby? Uh-huh. The diameter is twice the radius. The diameter is twice the radius. Okay? What's our substitution step going to look like? What's our substitution step going to look like? Come on, say. Okay. What then is the diameter of that particular circle? Plane. Uh-huh. Label? Uh-huh. Questions on this? Anybody? Anybody? All right. Take a look on page 89, please. 7 and 8. It asks you to use the compass to draw the circle, then draw and label the measurements.
Yeah.
Well, we're not doing that. Instead, we're going to use our formulas to find the missing measurements. Does that make sense? Okay. Number 10, I would also expect to see a formula to find a missing measurement. So all of page 89 and all of page 90. And then I am going to send you one independent activity here in just a minute. Okay, I wasn't sure you'd have time to do one or not, but we do. I will send you one independent activity. Go ahead and get started on the assignment before I get it sent to you. That assignment is due tomorrow. I there. We put it down and go back to the camera. IH2 on your folder. Um, let's just put it in week 35. So handgun or any kind of activity for week 35, week 2. Oh, no, 36, should be 36, sorry. Should be 36. So think under any kind of activity. They're allowed to be 36, but there's 2.
At this time, we need these students to report to the gym, please. Aiden Bainey, Abe Robot, Otto Robot, Kyler Brubaker, Allison Cornett, Diana Cortez, Devin Crumley, Monse Davila, and Jackson Farrell. Thank you.
Somebody else have their eyes muted?